Hello everyone, once again welcome to our channel Physi Dive, and this is your teacher Alexi Rajan. Today we are going to do a certain numericals regarding the power of lenses. We'll deal with how we can solve certain problems and see the questions and solve it so easily, and you'll not find any difficulty for your exam. So without wasting time, let us dive in straight to the class. So to the class.
Hello everyone. Yes, this is the first question regarding the power of lens. A doctor has prescribed, you can see that a doctor has prescribed a lens, a corrective lens of power plus 1.5 diopter. Find the focal length of the lens. Is the prescribed lens diverging or converging? This is our question. So the basic equation is what? Okay, you can see that the basic equation is power is equal to 1 by F or reciprocal. You can see that power is given by P is equal to 1 by F. That is, if you have a focal length, then definitely you can find out the power. But here from this equation I can write, how can I find out the focal length? That is equal to 1 by capital P, where P means power, and you know power is equal to plus 1.5 diopter. Okay, so from here I'm going to substitute the value. F is equal to 1 by 1.5, or simply you can see that, okay, 1 meters. Why it is meters? Why? Because power diopter is equal to 1 by reciprocal of focal length expressed in meters. So here you are getting the unit meters. Okay, so this is the thing, or simply you can say that it is equal to, if into 10 into 100 you will get 66.7 or 66.67, because the 6 will go on, and then you can see this is a centimeter. Okay, so this is the first answer for the thing, that is to find out the focal length of the lens. Okay, now the question is that here it is positive or negative. It is positive value. Why? Because here it is positive value. And is the prescribed lens a diverging or converging lens? This is our question. So positive focal length means which lens is used here? You can see that here, if I'm using a convex lens, then definitely if a light ray is passing through it, it will just converge and pass through it, and then it will go through a point. If the incident ray is parallel to the principal axis, then it will pass through a point, and this is a focal focus, right? And here one more thing is that this focal length, which is describe this length, that is from the optic center, is positive. Why? Because it is in the same direction as that of the incident ray. So we can say a positive focal length is for convex lens, right? And convex lens is a converging lens, and you know this thing. So I hope that you got the answer for this particular question. So if you're getting a question like this, then first you need to know this basic equation, that is P is equal to 1 by F, and from that you will just rearrange and you will get this equation, that is F is equal to 1 by P. From there you will get the answers. Okay, so we'll go to the next question. So the next question is this one. Okay, define power of a lens. First you need to find out the power of the lens and write its SI unit. Okay, name, it's define, its definition. Okay, name the type of lens which has a negative power. So we need to find out, we need to know what is having the negative, which lens is having the negative power. And third section of this question is that the power of a concave lens whose principal focus is at a distance is 50 centimeter from its optic center. So you need to find out the power. So you will get this type of questions for your board exams, right? And you need to find it out. Okay, so how can I find out the thing? The first and foremost session of this question is that define power of a lens. And the power of a lens is defined as the reciprocal of focal length of a lens expressed in meters. That is, power of a lens is equal to the reciprocal of focal length expressed in meters. This is what the power of lens is defined by. And it is a measure of by which how much it is converged or diverged by the lens. What is the meaning of that? That means if I have a convex lens and this is the principal axis, and I am just passing a ray of light through it. Then I can see that it converges and pass through a point. And the same way I am taking another convex lens. Then here you can see that I am again passing a light through it, and then it converges and pass through it. In both sessions you can see that in the first case the converging is there, and the second session it converges more. You can see this particular lens is converging more. That means if this is an angle, then with this particular axis, then you can see that this angle is lesser. If this is theta 2 and if this is theta 1, you can see that the theta 1 is greater than theta 2. That means what? It converges more, it bends it more. The second lens bends more. That means the converging power of this particular lens is more. The same way, if you are taking a concave lens, then you can see that here it diverges more than this. That means how much it is converged or diverged by a lens. This is what is the meaning of power of a lens. Okay, I hope you are getting the points. Okay, now we are just going to find out the third session, that is the numerical part. So read the numerical part carefully and see how you can do this thing. The basic equation should be there in your mind, that is power of a lens is equal to reciprocal of 1 by f, right? And what is the thing? Let us see. Calculate the power of a concave lens whose principal focus is at a distance of 50 centimeter from the optical center. So principal focus is given there, and that is equal to 50 centimeter, right, from its optical center. 50 centimeter can be written as what? How can you just write the 50 centimeter in meters? So it is 50 divided by 100. Okay, I'm just keeping it like that, meters. And now, what is the power? Power is equal to 1 by f, right? And then that is equal to 1 by 50 by 100. Why? Because it should be expressed in meters, right? By the definition you can say expressed in meters. So from there you can see it is 100 by 50, right? And that is equal to 2, its diameter. And now the thing is that whether it is a negative sign or a positive sign, which lens is given there? A concave lens is given there, a concave lens. So here you have a concave lens in your hands, and here you can see the light diverges and the focal length or principal focus will be formed somewhere here. And if I'm just calculating the focal length, the direction of focal length will be in this direction, which is opposite to the incident ray direction. So focal length of principal focus or focal length will be negative sign. So this will be a negative sign. So here also a negative sign should be given there. A negative sign will be there, that is -2 diopter. Why? Because it is a concave lens. So I hope that you are getting the points there. So here comes a second thing. So you will be asked to find what is the diopter, what is the power, or sometimes you will not be given directly the concave lens or a convex lens. Instead you will be given it is a converging lens or a diverging lens. So you need to know the basic principle ideas, which lens is a diverging lens and which lens is a converging lens. And you will be asked to define the power of lens, and the power of lens will be defined like this. Okay, so without wasting time, let us dive into the third question. So the third question goes like this. Find the power of a convex lens which forms a real and inverted image of magnification -1 of an object placed at a distance 20 centimeter from its optical center. So this is a question. So you are given with the power of a convex lens. You need to find out the power of a convex lens which forms a real and inverted image of magnification is given there, -1. So first write down all the values given there. So magnification is given there, right? And the object distance of 20 centimeter is given. The object distance u is also given there. Okay, so what is the basic equation that you can find out there? So m is equal to v by u. From there you can find the v value. So m is given there, that is equal to -1. V is not given there, you need to find out. U is given there. What is that? 20 centimeter. And the thing is that U is equal to, is having a minus sign. Why? Because U is considered as the source of object, source of light, and that will be the U distance, object distance will be always, the direction is will be always opposite to the incident ray direction, so it will have a negative sign. So 20 centimeter. From there you are going to find out the V distance. So let us see. So M is equal to V by U, and from there -1 is equal to V by -20, and from there V is equal to what? -1 into -20, that is equal to 20 centimeter. The thing is that V and U is 20 centimeter. So what will be the position of the object, or at which position you should keep the object, then you will get the same distance as your image distance. Then that will be, which lens is this? It's a convex lens, and here if I'm saying that this is optic center, this is principal focus, and here it is 2 times 2f, and if this is a f, this is 2f. Let this be f1, f1, f2, f2. If I'm keeping the object like this, then definitely I will get an image somewhere like this. Yes. So if you are if you have some doubts regarding the image formation, then I will just pin it somewhere here. You can just go through the videos where the image formation by convex lens is taught, and you can just clearly get the ideas from there. Okay, now the thing is that this is a ray diagram, and you're asked to find out the power of lens. So power of lens is given by 1 by f, expressed in meters, but f is not given there. But you can find out the f by simply the lens equation, that is 1 by f is equal to 1 by v minus 1 by u. From there you can get the values like this. 1 by f is equal to 1 by 20 minus 1 by minus 20. So 1 by f is equal to 1 by 10. From there you will get the value, that is f is equal to 10 centimeter, and this 10 will be positive. Why? Because you are getting a positive f, right? So from there you will get plus 10 centimeter. So this is a thing. Now you, from this particular equation, that is the basic equation, that is power, you need to find out the power of a convex lens, right? So power of a convex lens is defined as 1 by f, and then it should be expressed in meters, and this is in centimeters, right? So let us see what happens there. So power is equal to divided by 10. From there, that is equal to 10 diopters, that is equal to positive value. Why? Because it is which lens? A convex lens, and convex lens will always have a positive power there. So I hope that you got the point. From a simple equation, m is equal to v by u, you are getting these values of v, then, and then using this lens formula you are getting the value of f, and then you substitute the basic equation in the basic equation, and you are getting the final answer for this thing. Okay, I hope that you got the ideas, the basic ideas of how to find out the power of a lens, how to find out if only magnification and one of the values, whether it is object distance or image distance. Sometimes instead of this object distance you will be given v value, and you need to find it out. So these all things you need to rearrange, get the ideas. You need to know about the basic ideas, that you can just get it from the previous videos, and then you can find it out. Now I'm just giving you a small homework or a work, so you can find it out yourself, and if you're not getting the points, no need to worry, we'll discuss in the coming classes. So these are the questions. Okay, 2 questions are given there. You need to pause the video and write it down and do it yourself and see whether you can do it or not. Okay, by this, we'll wind up today's class. So I hope that the basic idea, the basic questions which are coming for your power is given, is discussed clearly. So you can just go through that thing, do the problems, and we'll see in the next class.
So that's it for today's class. I hope that you got the points and the ideas clearly so that you can deal with the problems easily. And the next class, we'll come with new questions as well as a new chapter for your 10th standard. And keep supporting as you're supporting till now. And do supporting with your like, share, comment, and subscription. So till we meet again, it's goodbye and have a good day.